Okay, so now we're going to look at solving simultaneous linear equations when they have fractions. So what it's really important to remember is to treat fractions like normal numbers. They are normal numbers, but people kind of get a bit put off because they are fractions. So if we treat them like normal numbers, the sums become much easier for us. So look at the simultaneous equation that we've been given here. So we have x equals minus 2y, and then x over 4 plus y equals minus a half. So the top line looks a bit different to us at the minute. We're so used to seeing our x, then our y, then our equals, and then our number. And we're going to reformat the top line to ensure that it looks more like that. So we're going to have x, then our y. So we see our minus 2y has to come back across the equals, so that becomes plus 2y. And then equals, there's no number, so then it's obviously 0. And now we'll write our bottom line. Right, so like with normal linear simultaneous equations, you need to try to get rid of the x or the y. In this case, it's far easier for us to get rid of the y, because if we multiply the bottom line by 2, that will give us 2y, and the top line is 2y, so it's far easier for us to do so. The fraction might be putting some of you off, but like I said, treat it like a normal number. If you were to get rid of the x, just say if we were, I'm just going to do it in a different colour pen because we're actually not doing this, but just to let you know how to do it, we'd multiply that top line by a quarter, and that would get rid of, well, that would get the x's to be the same number, as we know that x multiplied by a quarter, a fraction by a fraction, multiplied the top by each other and the bottom by each other, would be x over 4. So it's doable that way too, but I think it is far easier for us just to multiply the bottom line by 2. So let's go back to blue pen. So our top line doesn't change as a result, equals 0. Our bottom line, as I said, if you multiply by a number, you have to multiply everything by a number. So you're going to have 2 by x over 4, so that's going to give us 2x over 4, plus 2 by y will give us 2y, equals minus a half by 2 will give us minus 2 over 2, which is actually minus 1. Now, if you put these into calculator, your calculator will actually do it for you. So I'm just going to rewrite that the way the calculator would give it to you, equals 0, and then x over 2, because we know what goes once goes twice, plus 2y equals minus 1. Your calculator will do that for you. So now we have to ensure that our x's or y's, whichever one we chose, have different signs. So at the moment they don't, so we have to do that. So we're going to change the signs of the entire bottom line. As a result, minus 2y and plus 2y will balance out because they just give us 0, so we can get rid of them. Now we have 1x minus a half x. So that will give us a half x, which is x over 2, or 1x over 2, equals 0 plus 1 will just give us 1. So we know what we're trying to do is we're trying to find x. We can see that half and x are stuck together. So if we want to get x on its own, we're going to have x. They're stuck together, sorry, so they're multiplying. So if we want to get x on its own, it means the half is going to have to cross the equals and become a divisor. So 1 divided by a half. Your calculator will do that for you. So 1 divided by a half will give you 2. So we've just found our x value. So really, like, you're doing nothing different. You have your calculator to help you with the fractions, and you're just following the exact same procedure as what we've done the last time. You're not finished yet because you haven't found y, so you're going to sub your x value back into one of your initial equations to find y. So it might be just as easy to do it into the second equation, but if you want to do it in the first, that's fine too. So we'll write out the equation. We know that x is equal to 2, so we'll sub that back in. So, right, so we're going to have 2 over 4 plus y is equal to minus a half. We're trying to find y, so we're trying to get y on its own. The 2 over 4 is adding there, so if we bring it across, it's going to actually become a subtraction. So if we input that into our calculator, we know that a half minus a half is actually minus a quarter. So our y value is minus a quarter. Sorry, a half minus half is obviously minus 1. I was multiplying that in my head. So your value is x equals 2, y equals minus a half. Or sorry, minus 1. So again, you can check your answers by subbing them back into one of the initial equations and they should work out for you. But so that is the gist of it. I'm actually just going to do one extra one just to ensure everyone understands it. So I will pick, so p over 2 plus q over 3 equals 6, and p over 3 minus q equals minus 7. So we're going to try get our p's or our q's to be the same number. So I think the easiest way to do so is to pick the q. So how would we make this one? So q over 3, that's the same as a third q. How would we make that to be just a 1? So we know that if we multiply a third by 3, that will give us 1. So that's how we're going to do it. So we're going to multiply that top line by 3. So we'll have 3p over 2 plus 3q over 3, which is just going to be 1q, or q, equals 18, all over p over 3 minus q equals minus 7. So like in the other sums, once we have the number to be the same, we just cancel or balance them, because minus q plus q will just give us 0. Then we have 3p over 2 plus p over 3. So if we just go to your calculator, and you should be able to get that answer. So you get 11p over 6, or 11 over 6p is equal to 11. So that's the exact same as we write 11 over 6p equals 11. So the 11 over 6 and the p are multiplying. We want to get p in its own, so it's going to be 11 divided by 11 over 6. Put it into your calculator, p is going to be equal to 6. Once you find p, you need to find q. So we'll pick one of the initial equations. So we'll pick p over 2 plus q over 3 equals 6. We have just found that p is equal to 6. So let's sub it in. So we'll have 6 over 2 plus q over 3 is equal to 6. So we know that 6 over 2 is actually just 3. We're trying to find q, so we're trying to get it on its own, but we have to do it little by little. So we'll have q over 3 first is equal to 6. The 3 will come across from here and becomes minus 3. So q over 3 is equal to 3. I want to get q on its own, but we're being prevented from doing so because of the 3 here. Ask yourself, what is the 3 doing? Well, it's dividing. And we know if it divides or crosses the equals, it becomes a multiply. So we'll get q on its own, and the 3, and then this 3 will come up and multiply. So we have q is equal to 3 times 3, which is 9. So that's how we complete our simultaneous equations with fractions. Perfect.